Hi students, welcome to Methodology classes. From today, we are going to discuss class 10th mathematics. We will be taking each chapter, and from that chapter, first we will be discussing concepts related to an exercise and the questions from that exercise. Once we complete all the exercises from that chapter, we will be discussing the miscellaneous questions from the NCERT exemplar, R.D. Sharma, and previous year questions asked from that chapter in the board examinations. So let's start the first chapter of the class 10th, that is real numbers. In class 9th also you studied about the real numbers. In class 9th we basically focused on the irrational numbers. In class 10th we are going to mainly study about two theorems. The first one is Euclid's division algorithm. So using Euclid's division algorithm, we will be trying to find out the HCF of large numbers. We already know how to find the HCF of smaller numbers by prime factorization method, but when there are large numbers, the prime factorization method becomes tedious. So in those cases, we can use Euclid's division algorithm and can find out the HCF very easily. The second thing we are going to study in class 10th first chapter is fundamental theorem of arithmetic. This is a very important theorem, and using this theorem we will be proving the irrationality of the numbers, and we will also use this theorem to study about the decimal expansion of real numbers. So let's start. So the first thing we are going to study is Euclid's division lemma. Now what is a lemma? A lemma is an already proven statement. Already proven statement. So a lemma is already proven statement, so we don't need to prove it again. So what does Euclid's division lemma states? So Euclid's division lemma states that given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where 0 is less than is equal to r is less than b. So if you read this, so you will think that this is something new, but we already have been using this theorem, and this is nothing but this is just a division. Like if I have to divide 25 by 6, so we will go, quotient will be 4 and 6 4s are 24, remainder will be 1. So given two integers, positive integers a and b, so here a is 25 and b is 6. So a is 25 and b is 6. So we can write a is equal to, means 25 is equal to b, that is 6, into, we will get two unique integers q and r, that is 4 plus 1. And this 1 is the remainder, and we know remainder should be non-negative and it should be less than the divisor. So the same statement has been written here. So dividend is equal to divisor into quotient plus remainder, and remainder should always be non-negative and it should be less than the divisor. So this same thing is the Euclid's division lemma. Now let's come to Euclid's division algorithm. So what is Euclid's division algorithm? So what is algorithm? Algorithm is a series of steps which repeats itself again and again, or algorithm is a proper way of doing something. So what does Euclid's division algorithm states? To obtain the HCF of two positive integers, say c and d, with c greater than d. So if there are two positive integers c and d, and c is greater than d, so how we will find out their HCF? Apply Euclid's division lemma. So whatever we studied above, so we have to apply that division lemma to c and d, so that we can find two numbers, whole numbers q and r, such that c is equal to dq plus r, where 0 is less than is equal to r is less than d. So this is the same thing, Euclid's division lemma. Now in the second step, if r is equal to 0, means if the remainder in the first step is 0, then d is the HCF of c and d. Then the smaller number of the two is the HCF of both the numbers, But if r is not equal to 0, means if the remainder at the first step is not equal to 0, then apply division lemma to d and r. So again we have to apply the same, we have to repeat the first step again with taking d and r as the two numbers. And third step is continue this process till the remainder is 0. So we will repeat the step 1 until and unless the remainder becomes 0, and if the remainder becomes 0, then the divisor at that stage will be the SCF of the two numbers. So we have to repeat the same process, first step again and again until and unless the remainder becomes 0, and if the remainder becomes 0, then at that step the divisor will be the SCF of the two numbers. So these were the two, Euclid's division lemma and Euclid's division algorithm. So Euclid's division algorithm is quite similar to Euclid's division lemma. In algorithm, we have to apply the division lemma again and again until and unless the remainder becomes 0. And at the stage where the remainder becomes 0, at that stage the divisor becomes the SCF of the two numbers. Now let's apply these things to the exercise 1.1 of the NCERT. So this is the 1.1 exercise. So let's apply the Euclid's division algorithm and solve the question number 1 to find out the SCF of the two numbers 135 and 225. So let's do the first part of this. So exercise 1.1, question number 1, and we are going to solve the part 1. So we have to find out the SCF of 135 and 225. So what was the first step? If we have two numbers C and D, and C is greater than D. So here 225 is greater than 135. So C will be 235 and D will be 135. Sorry, this is 225. So what was the first step? First step is apply Euclid's division lemma to the two numbers C and D such that we get C is equal to DQ plus R, where R is less than is equal to 135 or D. So we can write 225 is equal to 135 times 1 plus 90. So here Q is 1 and R is 90. 90 is less than 225. But here the remainder is not 0 at the first step. So what was the third step? That if R is not equal to 0, apply Euclid's division lemma to D and R. So again we will apply Euclid's division lemma to 135 and 90. So we can write 135 is equal to 90 times 1 plus 45. Now again R is not equal to 0 at this step. So again we will apply Euclid's division lemma to 90 and 45. So we can write 90 is equal to 45 times 2 plus 0. Now at this stage the remainder is 0. So what does Euclid's division lemma states? That if R is equal to 0, then the divisor at that stage, so divisor at this stage is 45. So we can write 45 is the SCF of 225 and 135. So this was the first question. I hope you would have understood it. You can try the second and third part of this question. It will be done in the similar way. Now we use Euclid's division lemma or division algorithm to understand the properties of real numbers also. So let's try to do the question number 2 to apply the Euclid's division algorithm or the lemma to understand the properties of the real numbers. So question number 2 is, so that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So we have to show that any positive odd integer can be only of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. So this is question number 2. Let us try to solve it. So we have to show that any positive odd integer. So let a is equal to any positive odd integer and b is equal to 6. So according to the Euclid division lemma, we can write a is equal to 6q plus r, where r can be 0, 1, 2, 3, 4 or 5. So these are the only possibilities for r, because we do not know what is a. So depending on the value of a, r can be 0, 1, 2, 3, 4 or 5. So now there are 6 possibilities for the r, and we know that a is any positive odd integer. A is any positive odd integer. So we have to keep this thing in mind. So a can be, depending on the different values of r, a can be 6q if r is 0. A can be 6q plus 1 if r is 1. A can be 6q plus 2 if r is 2. A can be 6q plus 3 or 6q plus 4, or a can be 6q plus 5. So depending on the 6 possible values of r, a can be 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 or 6q plus 5. These are the 6 possibilities. But as we know, a is a positive odd integer. A is a positive odd integer, and we know sum of two even numbers is always even. So from here we can see that 6q is a multiple of 6. So this is an even number. So this cannot be the possibility. 6q is even and 2 is also even. Sum of two even numbers is even. So in this case a is even. 6q plus 4, again both are even. So their sum will be even. So these cannot be the possible values of a, because a is odd. So we can write as a is an odd positive integer. So only possibilities are Only possibilities are 6q plus 1, 6q plus 3 or 6q plus 5. So using Euclid's division algorithm or lemma, we proved that any positive odd integer can be only of the form 6q plus 1, 6q plus 3 or 6q plus 5. So this is a beautiful application to understand the properties of real numbers using Euclid's division algorithm. Now let's see what is the third question. So we solved second one also. An army contingent of 616 members is to march behind an army band of 32 members in a parade. So there are 616 members of army, and there are 30 in army band of 32 members. Behind an army band of 32 members. So there are 32 members of the army band, and behind that there are 616 army persons who have to walk. The two groups are to march in the same number of columns. So both the groups, that is 616 army members and 32 army band members, have to march in the same number of columns. What is the maximum number of columns in which they can march? What is the maximum number of columns in which they can march? So maximum number of columns will be the number which will be dividing 616 and 32 both, and it should be the largest divisor of 616 and 32. Out of all the common divisors of 616 and 32, it should be the largest divisor, because then only we will get the maximum number of columns, and this maximum number of columns should be same for both 616 and 32. So from this question we can understand that the maximum number of columns, that is the number of columns, will be the HCF, that is the highest common factor of 616 and 32. So let us try to solve it. So question number 3, 616 and 32, we have to find out the HCF. So we can write highest number of columns will be the HCF of 616 and 32. Now we can see 32 is the smaller number, so we will be dividing 616 by 32. So if we divide by 32, it will go 1 times. So 32, 61 minus 32 is how much? 11 minus 2 is 9, and 5 minus 3 is 2. 6 will come down, 296. So 32, it will go 9 times, it will become 288. So 9 2s are 18. 1 9 3s are 288. So 296 minus 288 is 8. Now 8 is the remainder. So again we have to apply the Euclid's division lemma. So at this place 8 will become divisor, and the divisor of the first stage, that is 32, will become the dividend. So here it will go 4 times, so 32, and it becomes 0. So the divisor at the last stage, when the remainder becomes 0, is the HCF of the two numbers. So using that concept, we can say that the army and the band can walk maximum in 8 columns. So I hope you would have understood it. So this was the application of Euclid's division lemma and the HCF, and we solved a word problem based on the concept of HCF. So that was the question number 3. Question number 4. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1. So you can try this by your own. The hint is also given. We can assume x to be any positive integer, then it will be of the form that, and we can square that and check. Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. So this we can try. So question number 5. So we have to show that cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. So we have to cube the number. So let a be any positive integer. And b be 3. So we can write a is equal to 3 cube plus r, where r can be, now we are dividing by 3, so r can be 0, 1 or 2. So these are the only possibilities. So if let us take all the possible cases of r and then see what will be the form of cube of that number. So if r is equal to 0, then a will be equal to 3 cube. So cube of a will be 27 cube. Now that can be written as 9 into 3 cube. So that can be 9. This 3 cube is again a positive integer, so that can be written as 9 into q, where q is. So from here we saw that if r is equal to 0, then the form of cube of any number will be 9 cube. Now if r is equal to 1, then a will be equal to 3 cube plus 1. So cube of this, we can apply the formula of a plus b cube. So if we know the formula, then a plus b cube is a cube plus b cube plus 3ab and a plus b. So that will be, if I cube it, 27q cube plus 1 plus 9q into 3q, 27q square plus 9q into 1, 9q. So all these numbers are multiple of 9, so we can take 9 common, because we have to show 9q or 9m plus 1 or 9m plus 8. So all these are multiples of 9, so we can take 9 common. 3q cube plus 27q square, here we will be left with 3q square and 9q plus 1. So again, this whole thing will be some positive integer, so we can assume it as m, so it will be of the form 9m plus 1. Now if r is equal to 2, then we can see a will be of the form 3q plus 2. Now if I cube it, so a cube will be equal to 3q plus 2 cube. Now if we again apply the same formula, so we will be getting 27q cube plus 8 plus 3 into 3, 18q and 3q plus 2. This 18q is 3ab. So if we simplify it, 27q cube plus 8 plus 18 into 3, 54q square plus 18q into 2 is 36q. Now if we again check, all these numbers are of multiple of 9, so we can take 9 common. So here it will be 3q cube and 6q square and 4q plus 8. Again, this is a positive integer. We can assume it as m, so I can write it as 9m plus 8. So we can see this is the first equation. When r is equal to 0, then again it is of the form 9q, or if we want, we can take it as m, because this is an integer only, representation of integer. From equation 2, it is of the form 9m plus 1, and from equation 3, we can see it is of the form 9m plus 8. So from these three equations, we can say cube of any positive integer is of the form 9m plus 1 or 9m plus 8. So using the Euclid division algorithm, we saw that cube of any positive integer can be only of the three form 9m, 9m plus 1 or 9m plus 8. So these were the questions from the exercise 1.1 of NCERT. Now we will move ahead with the fundamental theorem of arithmetic.